This is section 4.2 part 3, where we are going to look at changing quadratic functions to standard form. Essentially what we're going to be doing is rewriting equations. No graphing, just algebra, manipulating equations to end up in standard form. So I've got standard form listed here, vertex form, and intercept form. We've seen all of these formulas already because we've graphed in each of these forms. Alright, but what I'm going to do is, since we're working with each of these forms just in this section, I'm going to compile them all in one spot. We're going to write all three formulas here. So standard form, what does that look like again? It's in the form y equals ax squared plus bx plus c. This is what we graphed first. This is the complete standard form. We saw that sometimes terms were missing. Like if you take out bx, you would have y equals ax squared plus c. We graphed that. We also graphed with the last two terms missing, where all we graphed is y equals ax squared. Even if a term is missing, it's still in standard form. But what we're going to want to end up with, hopefully, is a complete standard form, y equals ax squared plus bx plus c. That probably will happen most of the time. Sometimes you might see that a term does, in fact, cancel, though. So, vertex form, what is that again? That's y equals a times the quantity x minus h squared plus k, and we call it vertex form because you can identify the vertex from h comma k. That's your vertex. Intercept form, if you remember, it's y equals a times x minus p times the quantity x minus q, and we call it intercept form because we can set the quantities x minus p and x minus q to 0, and we will, after we solve for x, we will have our x-intercepts. So that's a nice form as well. So before we actually get into any problems, I do want to do a quick review of something called the FOIL method. Alright, so FOIL, we have seen it before, we've used it, we probably know it, but just in case you don't have it down 100% or you're unsure of yourself, we'll do a real quick review. So FOIL, what does it stand for? It's an acronym, alright, and it's an acronym which will allow you to multiply two binomials together. Alright, so we're going to look at the binomials x plus 4 times x plus 7. Alright, two different quantities. So basically the acronym FOIL tells you the order in which you should multiply the parts of the binomials together. It doesn't necessarily have to be in that order, but most people do it in this order because of the acronym, where you're going to do the first letters in each binomial, multiply those together, then you're going to multiply the outside letters together. So that would be x and 7. Then you're going to multiply the inside letters together, which would be 4 and x. And then the last letters together, which is 4 and 7. So you can see it as first, outside, inside, last. Some of you may have learned it first, outer, inner, last. It's the exact same thing, whatever verbiage you want to use to help you remember it. So let's use this knowledge and actually multiply these two binomials together. So we've got quantity x plus 4 times quantity x plus 7, and we're going to multiply the first term. So x times x is x squared. Now the outside terms, x times positive 7 is positive 7x. Now the inside terms, 4 times x is positive 4x, and the last terms, 4 times positive 7 is positive 28. The last thing we need to do is combine like terms, and those are our middle terms here. They both have a variable of x raised to the power of 1, so we can combine those, and we've got x squared plus 11x plus 28. And this is in standard form, actually. So we didn't start in vertex form necessarily. Alright, we just had two binomials. This wasn't even a real equation. We just have two different expressions. But the FOIL method will be useful, and you'll see that in a second. So let's get down to vertex form. So we're going to go from vertex form to standard form. The problem we're going to be looking at is y equals the quantity x plus 1 squared plus 2. Where our a value is 1, it's positive, so if we did graph it, it would open up or down, up or down. It would open up, right? Positive A's open up. So we need to simplify this, all right? Get it into standard form. What you do not want to do is take this 2 and quote-unquote distribute it to the x and the 1. We're not going to apply it to either of these pieces. All right, what this 2 is doing is it's telling you how many times you should write your base. So side note over here, x squared. What's the base? The base is x. So the square is telling me I need to write this x how many times? Twice. Same thing here. The square is telling me I need to write my base how many times? Twice. What is my base though? It's the entire quantity. This entire quantity is my base. So the exponent is telling me to write this base twice. So I need to expand it. You're going to take that binomial and you're going to write it twice. And then drop down the plus 2. So we have two quantities here, two binomials multiplied together. What do we use? The FOIL method. All right, so first outer, inner, last. First outside, inside, last. So let's multiply the first terms together. X times x is x squared. We can draw our lines if we needed. All right, now the outside terms, x times 1, that's 1x. Inside terms, 1 times x. That's 1x. Last terms, 1 times 1. That's 1. Then we drop down the 2. Now last step is to combine our like terms. So we have two variables with x with a power of 1. We want to combine those. And we have two constants over here that we want to combine. So the x squared drops down. X plus x is 2x. And 1 plus 2 is 3. This y will drop down. And now that's our answer in standard form. So the equation y equals the quantity x plus 1 squared plus 2 is exactly the same as y equals x squared plus 2x plus 3. They're the exact same graph if you were to graph them, and feel free to check that on your graphing calculator. All right, we've just rewritten vertex form to put it in standard form. We're going to do the same thing with intercept form. We're going to go from intercept form to standard form. So the problem which we're going to look at is y equals 3 times the quantity x minus 1 times the quantity x plus 2. So what do we see here? We have two binomials that we need to multiply together. What are we going to use? Again, we're going to use FOIL. This 3, this a value here, which again is positive, which tells us our graph opens up, just a little refresher there. This 3 goes for a ride, all right? You're not going to use it until the last step. It will get distributed in, all right? First thing you want to do is FOIL, multiply the two binomials together. So this 3 drops down, goes for a ride. X times x is x squared. Outside terms, x times 2 is 2x. Inside terms, negative 1 times x, negative 1x. Last terms, negative 1 times 2, that's negative 2. Next, simplify. 3 goes for ride, comes on down, and we get x squared. 2x minus x is positive 1x, minus 2, and now it's completely simplified, so this 3 can now go ahead and distribute in. So we've got 3 times x squared is 3x squared, 3 times x is 3x, and 3 times negative 2 is minus 6. So we've gone from intercept form to standard form. And that is part 3.